In order to understand the substitution rule, we should go back to the chain rule first. You should think of the substitution rule as like integrating the chain rule. And what that chain rule says is that if you take a function, a composition of two functions, say f of g of x, you want to take that derivative. Then that's the derivative of the outside function, plug in the inside, multiply by the derivative of the inside. Oftentimes you'll see us write y equals g of x. You might see that chain rule written in Leibniz notation as well. Here I've got it written in Newton's notation. Leibniz notation would be like saying df dx equals df dy times dy dx. And so say now that you're interested in integrating the right-hand side of this. I'll give you an example in a moment, but for now I'm just deriving the formula. So say I want to integrate f prime of g of x times g prime of x dx. Using the chain rule, I know what the answer is going to be, because I know that integrand is equal to f composed with g, and take the derivative, write that here, f composed with g, take the derivative. And so you're searching for an antiderivative of the derivative of f composed with g. Of course, that's just going to be equal to f composed with g, or in other words, f of y, and plus a constant of integration. And f of y, another way to write that is to say that this is the integral of the derivative of f, but now with respect to y. Integrate dy. Because certainly an antiderivative of f prime of y is equal to f of y. The same way that an antiderivative of f composed with g of x is equal to f of g of x, or f of y. And what the substitution rule really just says is that the far right expression is equal to the far left expression. So I'll write down what's classically called the substitution rule here. So it says the integral of f prime of g of x times g prime of x dx is equal to the integral of f prime of y dy. That's the substitution rule. The idea being that you're substituting y equals g of x into the equation on the left-hand side in order to get something simpler, and also point out something kind of cool that comes out of this, because if you look at this expression, g prime of x dx, that is equal to dy when you treat them as differentials. And I think that's kind of interesting. When we first introduced the notation of antiderivatives, we put this dy or dx at the end just to tell us which variable that we're trying to use. But now we see like a deeper meaning, or we see a reason why you might have chosen that notation to begin with, because when we do this substitution rule, one way to keep it straight in your mind is to say, well, you know, that dy is going to be that g prime of x dx. So let me now show you an example of how to do this stuff in practice. So let's get rid of my theory derivation. I'll keep the statement of the substitution rule written down there. So here's a typical problem that you might see on your homework. So say that you want to look at the integral of x times sine of x squared dx. So this is something that you can use the substitution rule on, although it doesn't quite look like it at first. But your big hint is that, well, the inside function is supposed to be x squared. Oops. It's supposed to be x squared. your inside function, that's going to be your g of x, or in other words, that's going to be your y. That's right, y equals x squared. And then so what's going to be your dy? That, dy is g prime of x dx. So if g of x is x squared, then g prime of x is 2x. So g prime of x dx is 2x dx. So when you're setting up a problem trying to use a substitution rule, pick what function you want to be your y, then write down what dy has to be equal to, and then start doing your substitution. Because if this really is the left-hand side, then the right-hand side is going to have to be integral of, well, it looks like my f of x was sine of x, and I'm plugging in x squared, so I'm going to get a sine of y, and, well, I've got an x dx, so x dx is going to actually be equal to dy over 2. Think about dividing both sides there by 2. So I'll pull out that 1/2 here and put in the dy. And so this is my application of the substitution rule to this problem that I started out with. And let me explain it a little bit more because it doesn't necessarily look completely clear. Formally speaking, what you should probably do is multiply and divide this by 2. Like if you put a 1/2 here and a 2 there, then you could really see the 2x dx. But you don't have to be that pedantic about it, because whenever you see like an inside function here, that's your clue that you might try to use the substitution rule. And this sine of x, that's actually going to be your f prime. The sine of x squared is going to be your f prime of g of x. And then you've got your g prime of x dx over here, except you know that you're going to have to divide by 2 in order to make it work out. That's why I write down these equations first. Y equals x squared, dy equals 2x dx. I can then look at x dx, solve for that. It's dy over 2. So I can think of replacing x dx with dy over 2. And then sine of x squared gets replaced with sine of y. So that brings me all the way here to just integral of f prime of y dy. And I can now perform this integral. So the 1/2 stays put. The integral of sine is negative cosine, so I'll sneak in the negative sign there. Get cosine of y, adding a constant of integration, and now since y is equal to x squared, you can now plug that back in. So you get minus 1/2 times cosine of x squared plus c, and now you've taken this problem and you finally solved it with the substitution rule. So the theory and the practice of the substitution rule, they feel a little bit different. The substitution rule, it's in theory, it's nothing but integrating the chain rule, but in practice, it doesn't quite feel that way. In practice, you'll see an integral that you don't necessarily understand. You may see a composition of functions somewhere, and you might try to put your inside function to be y. And that's going to work out for you as long as you've also got the derivative of y sort of hiding in the integrand somewhere. And once you do that, just make the substitution y equals x squared, and then think of yourself, like, what's dy going to be equal to, or in this case, what's dx over x going to be equal to. You can always get that from this equation. Finally leads you, hopefully, to your final answer.